That's what's running out. This is on the anchor. And this is what's called a pencil point failure. So the galvanized wears away, it grows and grows and grows and grows. You'll find there's no steel left. You get a windstorm and it breaks off. And the guy wire pops up, the anchor pops up the ground, and now our hole's missing one guy. We only lose one guy, we go back into the field, we screw another anchor into the ground, retention, everything else. If two guys go, we have a hole in the ground. We now have two holes in the ground, and that's 5 antennas on the ground. And so you need easily 100 grand, bring the cranes, the crews, to re-guy everything, replace all the guy anchors, because you don't want to fix them, because it's break something. And that's something that you parts of the environment, that we do superintendent, request on the budget, and when we get some Washington, they cross out most of the budget. So, and that's a problem with parking with the deep line. We pretty quick here, wires, anchors outside, insulators, all the things everything. So whenever getting off the loop stuff, have what we need. And the problem is the Park Service does not allow volunteers to climb. I don't climb anymore either for other reasons, but I mean I used to. But so we have to hire somebody who's got the insurance, blah, 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 and the money clock spins really fast. So we're waiting now for funding to redo guy anchors and stand up poles and replace the antennas. So we have more transmitters than antennas right now. Okay. Anyway, this is RCA. Press wireless PW15 Press wireless is a service. If you're a correspondent anywhere in the world that would send a story back to your newspaper, you go to local Press Wireless, they would then send it to your newspaper.
So you said they were not part of RCA?
No. These are original Press Wireless transmitters. Press Wireless was shut down, was bought out by Mercury Radio. They moved it to what's called MX in Palo Alto. These are on the air for MX. When they replace those modern transmitters, they give us these two. This transmitter is fully restored. It will be on the air at 10 o'clock today. This transmitter is still being sorted out. Jay and Bob are in there more than armed trying to figure out what's going on with it. We'll figure it out.
With this transmitter, are you transmitting on average?
No.
Is that low power or something else?
No. This is commercial maritime service.
Oh, okay.
So this will be on 12 megs today.
And what power do you want?
We're running 512 on it. 15 is what we're only looking So these six transmitters actually, during World War II, Press Wireless made most of the fixed transmitters between the Army and the Navy. The Army transmitters, second flying. So they operated, this is, I think they was 42. Yeah, 42. So this transmitter is half, but the given me 42. And we will be transmitting at 10 o'clock. So here's what no chips. So we have upstairs is a 100 milliwatt crystal oscillator. This down here goes to a buffer, into a double stage, and another double stage, and an IPA. Anyway, a couple of stages, and then come back here. But you had to change taps depending on what band you were on. So this conductor, you go your tap back towards. So very straightforward. Straightforward. If you're just keep the really long arms with the camera. So that's the PW15, and it represents several milestones in high power shortwave transmission. Back here, that is our medium frequency transmitter. It's a Henry. I don't like them, but that's what we have. We have some other transmitters that we've been trying to restore. So, let's see. Systems we have, marketing or background. I'm not giving you a hide behind that, the background, like the safety of it. But all the big things out there that we're trying to save, we're running into the problem. We have to be related to safety or RCA. That's what's called. And you have to be careful who you accept this information, even though you like to get more. So a couple of arguments we had there is pretty cool. So, one of the interesting is something called Heinz-Kaufman. Right? And this is the Heinz-Kaufman green band frequency shifting exciter. Heinz-Kaufman made transmitters and they made tubes. They were able to evade RCA patents, which was pretty tricky, and they made their own tubes. So, Robert Dollar, the Dollar line, got pissed off at RCA, so he built his own radio network, which ended up costing more money, that's okay. And so all the equipment for the Dollar line was made by Heinz Kaufman in San Francisco. And so I'm trying to get more history on that. Heinz Kaufman basically disappeared 30 years ago. But so anyway, that's a piece of San Francisco radio history there. One of the interesting relationships between Heinz Kaufman and today is that two of his tube manufacturing guys decided they could make a better tube, and they figured it out, and we're trying to get Heinz Kaufman to let them make their own tubes. Heinz Kaufman said, no, thank you, so they quit. A guy named Eitel, a guy named McCullough. Ever heard of IMAC? They started at Heinz Kaufman.
Oh.
So, this is an RCA SSB R3. It's a dual diversity independent sideband receiver. At at Point Reyes upstairs, they had dozens of these receivers, all ripped out with the satellite. We bought these on eBay and paid a fortune on them here. One is restored and operable in one night, but this was a hybrid, some tube, and some transistor 1960s vintage receiver. Upstairs, we have RCA SSB T3s, which were 20 kilowatt independent sideband transmitters. Let's go to these upstairs. So this is another artifact here. This is a 5 kilowatt arc converter. Okay, back in the days,
5 kilowatt what?
a 5 kilowatt arc converter. Okay, this made a continuous wave with a spark in a hydrogen atmosphere. This is the top, goes on top of that. And it's really interesting. When you strike an arc in a hydrogen atmosphere, you tend to have hydrogen and oxygen combined rather rapidly. So it was kind of a scary thing, but this was the next advancement over rotary spark transmitters for arc. And they made up to megawatt arc transmitters made by a company called Federal, which was in San Mateo long before we had Silicon Valley. In fact, if you know where Lawrence Hall of Science is,
Yeah.
okay, in front of that is the original cyclotron that Lawrence built. The magnet structure actually is a 1 kilowatt federal arc converter magnet. And so they donated that to the university and he used that. But anyway, so this is another version of conversion, the transition from roots force spark, rotary spark, we had arc transmitters, and then we had tube transmitters. So this is one of the things we have here that is pretty rare because everybody threw this stuff out 100 years ago. We have teletype. We have some other architecture collected here. This is the Mackay radio receiver. Mackay radio was a competition to RCA for a long time. So let's wander into the parts room. Oh, this is the front panel to one of the original RCA shortwave transmitters that built it. Everything else got scrapped. We were able to do the front panel. So when you have 40 transmitters on the air, 24 hours a day, 7 days a week, they have full-time technicians here. And when turns go bang and go off the air, the tech on call would go figure out what the problem was, come down to the parts room. We had an inventory of all the parts you need to fix the transmitters. And they would grab the parts, fill out a request sheet, go back, transfer it back on the air. They didn't have spare transmitters. They just would fix it, get it back on the air as quickly as they could. RCA had a full-time spark keeper, nothing to keep the inventory of all the parts they needed. So we have a few other interesting artifacts here. This is the plaque on building 1 honoring the installation of Alexanderson alternators. The mechanical way of making RF, but it was state-of-the-art in 1920. This used to be on the building, it disappeared. We thought, some asshole scrapped it. Then we had one of those phone calls we get periodically. Well, if you meet us in a dark place at midnight, and so we got the plaque back. We're not going to put it on the building because somebody will steal it, but we do have the original plaque. So this is transmitter BL11. It was the medium frequency backup transmitter, the transmitter BL10. And it had disappeared, but when we were cleaning things up when we started here, we found the table with the changeover switch. So, that's the BL11 table because we have pictures. And then we found some motor generators. Oh, those are the motor generators for the BL11. This is a shipboard transmitter. Ships had 120 volt DC power, and so to make anything else, you had a motor to a generator to make AC to make the different voltages and everything else. And then we were somewhere, and the lady in charge said, "There's stuff in the basement. I don't know what it is. It's not an inventory. No question will be asked." 10 seconds after she said that, this was on a hand truck being loaded in the back of my van. So this is a transmitter BL11, medium frequency 500 watt transmitter, been converted to operate by remote control, and someday we'll get all the parts sorted out and on the air. So over here, behind these boxes, is an example of a shipboard transmitter. Ship owners have been always, to this day, cheap. And so this was originally a quenched arc transmitter that was converted to continuous wave. So they added a power supply, they had a little shelf in the back there with tubes, and that was the low frequency transmitter. And they added this shelf on top here with that tube, that was the medium frequency transmitter. And on the side is a knife switch that would switch between two transmitters. And it was like this onboard a ship. There was no cover, no protection, no nothing. You were supposed to know better not to touch it while it was turned on. And they also didn't have to worry about harmonic radiation and everything else that we do today.
And low frequency, do you mean this was down at 47?
No, this is like 100 kilohertz, 120, something like that. So we have more artifacts here. We keep collecting stuff, but. So we have 40 transmitters on the air, we need tubes. So we have these are the tubes, we also have spare tubes. We have some of the higher power tubes. These are used in directing transmitters upstairs. Those are the ones where we use the working power to check in the back of the unit with the key. We have a little information work present in the tubes so they can't let go of them. Well, no, it's not dangerous. You don't go in. Right. No, then you don't go with it. Yeah. So we have transformers, replacing transformers, transformers for one system. So we have a train. Then we have a bunch of other stuff in property for it. You can see on the shelves, bins with part numbers and everything else, it's all part of the organization, spare parts to keep everything working.
This tube here.
That's a water cooled tube.
Water cooled tube.
Yeah.
And the other one?
I don't know what that tube is, but that's an air cooled tube. See, this sat in a bucket of water.
Yeah.
And so it would make hot water and then you would cool the water and recircle it back through. One of the issues in the development of high power was, how do you make a high power tube? And there were a number of different versions of that, and so the original KPO transmitter, now called KNDR, had a water-cooled 50 kilowatt transmitter. And because the only way they could make 50 kilowatts in 1930 was with a linear amplifier. So it was a low-level modulated 5 kilowatt transmitter that drove a 50 kilowatt linear amplifier. And that transmitter took 380 kVA in to make 50 kilowatts out. It made lots of hot water. So over here is a couple tubes from what's called transmitter BL10. That was a 40 kilowatt medium frequency transmitter. The carcass is in building 1, but somebody's ripped all the meters and stolen everything they could steal out of it.
So this is a tube.
That's a tube. Yeah, RCA made them under contract for the Coast Guard and made 2 more. They made one for here, for KPH, and one for WCC on the East Coast.
So, Bill, you mentioned earlier, they started at 300 kilowatts, I thought, back in, with Marconi at
The
40.
original spark transmitter was 300 kilowatts.
And then they went to 200 kilowatts. And then you mentioned they were getting 50 kilowatts on this side.
Yeah, well, the thing is, the 300 kilowatt rotary spark transmitter made 300 kilowatts of noise. Some of that was filtered and became actually radiated RF.
Yeah.
But it was very inefficient, because you would make, the spark was basically a noise generator.
Yeah.
Alexander's alternator, though, is a continuous wave. It has a lot of harmonic content, but it actually is a sine wave.
That's the arc.
No, there was never an arc here.
There was never an arc here.
No. But the Alexander alternator put 200 kilowatts of RF into the antenna, where the 300 kilowatt rotary spark probably put 30 or 40 kilowatts of RF into the antenna. Everything else was wasted.
Right.
So now this transmitter was 40 kilowatts and it put us solid 40 kilowatts.
I remember, years ago, the standard was, we talk about today output at the antenna for power, but back, 50 years ago, they talked about power to the final.
Well, it's
So-
easier to measure power to the final. In broadcasting, to this day, in medium frequency broadcasting, you measure current into an antenna, and that's how you calculate your power. Twinkle, twinkle, little star, power equals I squared R. And so at one point in my life, I was responsible for putting a little bit over 30 amps of current into a vertical radiator at KNBR.
So the power we're quoting right now, like 200 kilowatts when they
That was DC in.
DC into the final.
Yeah. Well, you didn't have a final on the spark transmitter, but
I mean, but that was 200 kilowatts on the spark? I
no,
thought-
200 kilowatts with the Alexanderson alternator.
Yeah, on that one.
Yeah. And that one was reasonably efficient.
Yeah.
The spark transmitters were not efficient, and they did not make
a single way, they made a broad spectrum of noise, which most of it was tuned by the antenna.